Thanks for the privilege again, and welcome to our mathematical series as we continue with other new topics. Now, here in this class, we're going to briefly consider permutation and combination. Permutation and combination. Now, if we will ask, what do we mean by those permutation and combination? Now, what is permutation and the possible difference with combination? What is permutation and the possible difference? Let's write it. And the possible difference with combination. Then we can say that permutation is associated with the arrangement of things. The arrangement of things is associated with the arrangement of things. Permutation is associated with the arrangement of things, whereas that of combination is concerned with the selection of things. That is, permutation, number of ways things can be arranged, we say. Number of ways things can be arranged. Whereas that of combination, we said this is concerned with the selection of things. With the selection of things. This is associated with the concern with the selection of things. Now, let's consider, for example, how this really works. Let's consider an example how this really works. Now, if we consider the letters, say A, B, and C, we have been said that permutation is the arrangement of items. Now, if we want to arrange this, we can see that this letter A, B, C can also be written as A, C, B, A. Now, in terms of arrangement, you can see that these are two different arrangements. Yes, the items are the same, but in terms of arrangement, these are two different arrangements. So you say here we have two permutation. Now, in terms of combination, we're talking about selection of items, collection of items. So you can see that in this very pool here, where we have A, B, C, you can see that the items are also the same. C, B, A, they are also the same. So in terms of combination, we just have one combination. So in other words, we can say the order in which, for that of permutation, the order in which the items are arranged matters. The order in which, because this arrangement and this arrangement are different arrangements. But if it's in terms of collection, combination, or selection, you can say they are the same thing. CBA, you can pick this one first, pick this one, and pick this one. So they are the same thing. So you can say for that of permutation, you say the order in which the items that are arranged matters. For that of permutation, we say the order in which the items that are arranged matters. Whereas for that of combination, irrespective of how you place them, even if you say it's B, C, A, then in terms of combination, it's still the same thing because it's a collection of just the set of items. So in terms of combination, we say the order in which the items are arranged, are selected, the order in which the items are combined does not matter. Does not matter. Does not matter. So we are saying from permutation, you see that this is different permutation, this is different, these two arrangements are two different arrangements. If you want to consider this third one, you can say that all these are three different arrangements. So if you want to consider the third one, you can say we have a three permutation. Whereas for that of combination, irrespective of how you pick it, the items are the same. So it's just one combination. So we are saying that the order in which the items are arranged, the order in which they are arranged, that it matters a lot. It matters a lot. It matters a lot for that of permutation, whereas for that of combination, the order in which they are arranged does not really matter. Now let's consider another example, if that is true. Let's consider another example to illustrate further. Let's consider another example to illustrate further. Let's consider up to 4, say A, B, C, D. Now, in terms of permutation, if the order really matters, okay, if we say, let's try to arrange this, our interest here is to choose 2 letters from this 4. 2 letters, our interest is to choose. Interest is to choose 2 letters from the 4. Now, our interest is to choose 2 letters from the 4. 2 letters from the 4. Now, if our interest is to choose 2 from the 4, what do? We can continue by writing A, B as one arrangement, A, C, A, D. We can also have B, C, B, D, and we have C, D in terms of arrangement. Now we can also write them in another way by saying, bringing this one forward, BA, CA, DA, CB, DB, and DC. Now, in terms of arrangement, you can see that this arrangement and these are 2 different arrangements. All these ones are 2 different arrangements. So, in terms of selection, if our interest is to choose 2 out of the 4, 2 letters out of the 4, then we say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 permutation. Whereas for that of combination, you can see that this and this, the selection, the items are the same. Even if the arrangement differs, the items are the same. And we said for that of combination, our interest is to select So the selection here is the same, selection here is also the same, selection here is the same, and the same all true. So you can see that for that of combination, we have 6. For that of combination, we have 6. But I wish to announce to us here that if we are dealing with a very large number of sets, a large set where we have a lot of elements in it, sometimes it can be strenuous for us to do this arrangement. It can be sometimes very stressful. So what do? We have a formula with which we can curb all this. For that of permutation, we have NPI, where N here is the total number of items to be considered, where 2 here and R here is the number in which they will be arranged. The number in which they will be arranged. Whereas for that of combination, we have this. So this is also the same. Where N there is the number of items to be considered, whereas that of R is the number in which the items will be combined. This one, the number in which the items will be arranged, whereas this one, the number in which the items will be combined. Whereas the N here are the total number of items to be considered. So now let's try it, and we say this is also equal to N factorial all into N minus R all factorial for that of permutation, whereas for that of combination we have N factorial N minus R all factorial and R factorial Now before I continue and move further, what is factorial? Factorial is the multiple of a number, of integer number in descending order. The multiple of an integer number in descending order. Example, if we have 3 factorial, then we are saying that it's the same thing as 3 times 2. I said integer number, sorry, natural numbers in descending order times 1. So if we have, say, 5 factorial, it simply means 5, the multiplication of the natural numbers in descending order. 5 times 4 times 3 times 2 times 1. That is it. So that is the meaning of the factorial. The multiplication of a particular number, say natural number, in descending order. So this is all about factorial. So let's try to see if what we have done here in this case is true. Now, if we want to consider that, we see that N here is equal to 4. N here is equal to 4. In this case, N here, the number of elements to be considered is 4. Whereas R is the manner in which they want to be arranged, and we said we should arrange them in twos. Or if in terms of combination, we said combine them in twos. So if we want to put that into this, you can see that N here, which we have as 4 factorial, all into 4 minus R, which is 2, all factorial. And this is 4 factorial all over this minus this will give us 2 factorial. And we said 4 factorial is the same thing as 4 times 3 times 2 all factorial. All factorial because this is again times 1, which is the same thing, all over 2 factorial. So 2 factorial is off, and we have this times this, which is 12. So for that of permutation, as we also did, we said we have 12 permutation. And even from the formula, you can see that it's still 12 permutation. Now let's try to consider the combination of it, where in this one we have 4 factorial all into 4 minus 2 all factorial 2 factorial. Now, if you simplify this, you're going to have 4 factorial all into this one. We have 2 factorial, 4 minus 2, 2 factorial, but we still have 2 factorial. And we said this one is the same thing as 4 times 3 times 2 factorial, plus times 1 again, 2 factorial, all into 2 factorial times 2 factorial. So this one and this one is off the job market, and you'll be left with 12, 4 times this, which is 4 times 3, all into 2 factorial. All into 2 factorial. So 4 times 3 is the same thing as 12, whereas 2 factorial is the same thing as 2 times 1, which is 2, and you have it as 6. So you can see that even when we counted, we saw that for that of combination of these is that of 6, whereas even as we use the formula is also the same. Is also the same. So in terms of combination and multiplication, the thing to note is the key term for that of permutation is that of arrangement of things, the number of ways things can be arranged. So when that arrangement term, that which is the key term, comes to play, you know that you're talking about permutation. Whereas for that of combination, you know that what the key term there is that of selection in terms of for that of combination. The key term there is selection. Let's consider some examples quickly. And we have said that for that of permutation, the order in which the items are arranged matters. Whereas for that of combination, it does not really matter. It does not really matter. Now let's consider some examples to see how it may look like. Now, we say, in how many ways, if you want to consider this, we say, in how many ways in how many ways can we arrange 3 books? In how many ways can we arrange 3 books on a shelf from a group of 7? In how many ways can we arrange 3 books from a shelf? 3 books on a shelf from a group of 7. So from here, the key word in play here is arrangement, so that you know that we're talking about permutation straight away. Now, the number of items to be talking about is 7, while the number of ways in which they will be arranged is 3. So we say P, which is this R, is the same thing as n factorial, n minus R, all factorial. Our n is equal to 7, our R is equal to 3. So this we can also write as 7 factorial, all into 7 minus 3, all factorial. And we have 7 factorial, all into 4 factorial. And this is the same thing as 7 times 6 times 5 times 4, all factorial, all into 4 factorial. This and this is off the job market, and then we will be left with this times this times this. This times this will give us 30. 30 times 7 is about 210. 210. That is what we have. If we consider this, that is what we are likely to have. That is what we are likely to have. Now let's consider another example. Another example before we move forward again. In case we note that, I want you to, before I do that, let me introduce something. Note that 0 factorial is equal to 1. 0 factorial is equal to 1. And also, 1 factorial is also equal to 1. 1 factorial is also equal to 1. So now let's consider another example quickly. Let's consider another example. In how many different ways can we arrange this one? In how many different ways can we arrange 5 books on a shelf from a group of 5? from a group of 5. Now, if we are to consider this, straight away we will have, we are talking about the key term here is arrangement, so we say is permutation, where we have n factorial all over n minus r all factorial. And the number of items to be considered is 5 factorial, and that of the number of ways to be selected is also 5. So we have 5 minus 5 all factorial. And here we have 5 factorial all over 0 factorial. And we've been told that 0 factorial is the same thing as 1. So we have 5 factorial. We have 5 factorial. And when you multiply, you see how beautiful everything works. You see how beautiful everything works. Now, another thing that I would want to bring us to play, this one, which if you want to further simplify yourself, is 5 times 4 times 3 times 2 times 1. This times this 20 times this 60 times this 120 times this 120. So the answer is 120. That's what we have if you want to further simplify it. Now, another thing before we go, I want us to look at another thing where we have an example of this kind. Example of to say, in how many ways can we arrange the letter in the word? In how many ways can we arrange the letters in the word? Say, Alabama. Now, from what we have learned, we said the key word here is arrangement. The key word is arrange. So, invariably, you know that we're talking about permutation. But in this kind of presentation, we don't use the formula. In this kind of presentation, we don't use the formula. Rather, we take, as usual, the total number of items to be considered, which we have as 1, 2, 3, 4, 5, 6, 7, which we have as 7 factorial, all over the alphabets that are repeated factorial, the factorial of the alphabets that are the letters that are repeated. Like in this case, the one that are repeated is A in 1, 2, 3, 4. So we say 4 factorial. After A, L appears 1, B appears 1, M appears 1. So this is all that we have. So we just have 7 times 6 times 5 times 4 factorial all over 4 factorial, and this is this. And the answer is just straight away 110. The answer is straight away this times this gives you 30 times this gives you 210. Sorry, gives you 210. Let's consider another example before I go finally. In case we are asked to consider similar thing where the word to be considered is alabodite. Alabodite. If it is this, then what do? I said take the total number of alphabets, which are 1, 2, 3, 4, 5, 6, 7, 8, 9. So here will become 9 factorial. Then the elements that are the alphabets that are repeated, how many are they here? We have AA, which is 2. So in this case, we have just 2 factorial. L is 1, B is 1, O is 1, D is 1, this is 1, this is 1, this is 1. So we are only concerned with those that are repeated factorial. So this is all that we have. So what we're going to have here is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial, and that is the answer. Lastly, if we are to consider another word, let me increase multiple words so that maybe we get it. If we are to consider something like Mississippi, what do we do? Mississippi. And what do we do? In this case, I have said, consider the total number of words where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 factorial all into those that are repeated factorial. So in this case, M is just 1, so we leave it. I is 1, 2, 3, 4. So we have I is 4 factorial, S is 1, 2, 3, 4 times 4 factorial. Then we have P is 2 again, so we have 2 factorial. The once repeated factorial. So here we have 4 all factorial. So this you have as 11, that is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, all into 4 factorial times 4 factorial times 2 factorial. So 4 factorial is off, and we are left with this. So you have 11 times 10 times 9 times 8 times 7 times 6 times 5. Now this one we have 4 factorial is the same as 4 times 3 times 2 times 1. Where we have this times this will give us 12. This times this will give us 12. Times this will give us 24. Times this will give us 24. So you can cancel this will give us 24, and this other side will give us times 2 factorial again. So 24. If 24 comes here, 6 comes here, it will give us 4. 6 comes here, it will give us 1. So if this and this will give us 8, so this 2 is off the job market, and you will be left with 11 times 10 times 9 times 7 times 5. That is the answer that you are going to have. But the idea is this, that how to present it. The calculation is pretty simple. And we have stated that factorial is the multiple of that number in descending order. The natural number set in descending, the multiple of the natural number set in descending order. And you can see that is pretty easy and simple, if and only if we won't forget the concept. For that of permutation, we say the keyword is arrangement of things. For that of a combination, we said is about selection. And for that of the order in which we have said that the order in which the items are arranged matters very important. It's critical to that of permutation, whereas for that of combination is not that important. At least in our next class, we are going to learn more. Whenever you are having problems in this, you can also go and to our comment section and ask more questions, so that we will jointly treat them, and I believe we are going to respond to you reasonably. As I will always tell you, don't forget to click on the subscription button. It won't cost you anything, only you get notification whenever videos are uploaded. Thank you, as we look forward to looking at other topics. Thank you, and God bless.